The shell is the command interpreter, the program that you type commands to that causes them to be executed. If you log in from a text console or by SSH or similar, then first it checks your username and password, then it runs a shell. If you log in on a graphical console, it's a bit more complicated. It runs some sort of desktop environment. You have to run a terminal program explicitly, but then the terminal program runs a shell. The shell is a big loop. It prints a prompt, which is traditionally a $sign in the space. It reads a command. It parses that command. It arranges for that command to be executed, and then it loops, printing another prompt and so on. There are two main varieties of shell programming languages, known as SH and CSH. Versions of SH include the original version 7 shell, known as the Bourne shell, KSH, ASH, BASH, DASH, and others. These are all implementations of the basic SH programming language, plus additional features which the author of that particular program thought were a good idea. When we write our shell programs, we will always test them under at least two different implementations of SH so that we can be sure that we have not inadvertently used any extra features that might not be present when our shell script is run by somebody else. Varieties of CSH are CSH and TCSH. CSH is a greatly inferior programming language, although some people use CSH or TCSH for interactive use, which is fine. But for programming, we will use SH. You're familiar with typing basic commands to the shell and pressing return to have them executed. When the shell parses your command line, it performs various command line substitutions. For example, file name wildcards are substituted for the matching list of file names by the shell before executing the command. When we type something like cat star.c, the cat program does not see that star.c. Instead, it sees the expanded argument list based on the list of files in the current directory. If we want to understand how the shell is doing command line substitutions, a good way to experiment interactively is with the echo command. This is how echo works. If we type echo hello, it will say hello. The echo command just outputs all of its command line arguments separated by spaces. But if we type something like echo space star.c, the shell is going to interpret that star.c, expand it to the list of matching file names, and pass that to echo rather than star.c. Since echo just outputs its command line arguments, we get to see what its command line arguments actually were. So we'll be using the echo command a lot right now to explore how the command line substitutions work interactively, although we won't use it as much in our actual programming. In fact, SH is a complete programming language, although in some ways it's a weird one. This sort of interactive use doesn't look like programming, but we can use SH in a usual software tools way to execute commands from a file instead of interactively. Let's edit a file using the VI editor. I'm going to write echo hello, echo how are you. I have to quote that special character, the question mark, or it would be interpreted as a file name wildcard. Echo star.c, here I want the interpretation. Save and quit. If I run cat space hello, then the cat command reads all these lines and outputs them. To execute that list of commands, instead I can run the hello file through sh instead of cat, and then it performs the commands. So the shell works the same when reading commands from a file on disk as when reading commands from the terminal interactively. Any programming language needs variables. In SH, command line substitutions are involved in using variables. Command line substitutions are used for many things in SH. This is an assignment statement. And I press return and it's done. There are no spaces in this assignment statement. I space equals space 3 means something different. It means to execute a command named I with first argument equals sign, second argument 3. I equals 4, How do we know that this is doing something? How can we explore what the value of I is? If we write a $sign and a variable name, then the shell substitutes that, it's a command line substitution, substitutes that $sign I with the value of the variable I. So this is the same as typing echo 4, and the echo command outputs the 4. I'm using echo here to see how the command line substitution works, but in practice we would just use $sign I in a command in some appropriate way. We could even just say $sign I. That tries to execute a command named 4. We can use echo where we would normally use a print statement, and we can use $sign I there. Or we can pass it to any other command. If the variable I contained a suitable file name, we could pass it cat. This is cat giving that error message for no such file or directory because it did run cat. Cat doesn't see the $sign I, it sees the substituted value as the shell does the command line substitutions. Let's write a statement which increments I. That is to say, I is assigned I plus 1. First of all, what does this do? Well, if we want to see what it did, one way to see is echo $I. Of course, without the $sign, this means the string I, not the value of the variable I. But the $sign isn't going to help much. If I is 4, I equals $sign I plus 1. I will now be 4 plus 1. Now we need some program which will do the arithmetic. There is a utility program called expr, which is particularly useful for doing arithmetic in shell programs. expr space 4 space plus space 1 gives us 5. expr is a program which does the arithmetic. So how do we apply this to I, to add 1 to I and put it back into I? For this, we need another category of command line substitution. This command line substitution is invoked with a character called backquote. The backquote looks like this. It's usually on a key in the upper left of your keyboard. What is inside backquotes is interpreted as a command from scratch. That command is executed, its output is captured, the output is substituted into this command line, minus the trailing new line character, if any. That definition is a bit overwhelming. Let's play with backquotes a bit. If we write I equals backquote expr 4 plus 1, then that is going to run the expr command, because that's what backquotes do. It gives it the arguments 4, plus, and 1. expr, as we discovered just above, will output the number 5. The backquotes substitute that into the command line, making us have the command I equals 5. How do we know that that's what happened? Well, we could experiment by using the echo command. If we want to increment I again, I is now 5, we could do I is assigned expr 5 plus 1. But of course we want to write this more generally. All we have to do that is change the 5 into $sign I. Then the shell will execute that expr command, which involves a command line substitution, putting in the 5. expr 5 plus 1 will be executed. The output will be 6, but that will not appear on the terminal. It will be captured, because that's what backquotes do, and it will be substituted into the command line. So we'll have I is assigned 6. Please understand fully how this simple example works before we move on to more complicated uses of backquotes. expr $I plus 1 is a separate command. That's what backquotes do. It executes that command. It substitutes the result of that command, the output from that command, into the command line. There are no spaces around the equal sign here. As I mentioned in the previous page, if there were spaces here, that would be a command named I. The equal sign has to appear in the first word on the command line. There are spaces here. To make it easier to write expr, all of the different components are different arguments. The different numbers being added together, the operator, each one is a different argument to make expr easier to write. Please be careful in writing this backquote character on tests. It means something completely different from single quotes. Despite the name, in SH, backquotes have nothing to do with quoting. Quoting is about suppressing the interpretation of special characters. Backquotes are about executing a separate command and substituting its output in on the command line. Completely different. Here's something else we can do with variables. Remember how we can write a simple shell script as a sequence of commands in a file and then execute it with the sh command. I'm going to create a file named s, print what is your name, read, this gets input, hello, whatever, pleased to meet you. Just to see what we're looking at, cat s to see the file, I'll run it. It executes the first line of the file, which outputs what is your name, question mark. Question mark is not interpreted as a wildcard character because it's quoted. Now it's executing the read command, and the read command takes a list of variable names. I'm going to type something that's going to get assigned to that variable name. The read command actually specifies one or more variable names. So if we say read xy, I'm going to type 3 different tokens in. Each token goes into one corresponding variable. So the foo goes into the variable x. If there are more tokens than there are variables listed on the read command, all the rest go into the last variable. So if you say just one variable, it reads the whole line into that variable. If there are more variables than tokens, then subsequent variables are assigned to be the empty string. Your SH program can use any Unix command, including any useful little utilities you write in C. It's quite common for a complex package to include some C code and some shell scripts, and the shell scripts invoke the C programs as needed. Where does the shell find these commands? It looks through a list of directories specified by what's called your path. There's a special variable name, path in all caps. We can set it to this. We can see that it's just a variable, but it's special to the shell, and what it does is when you type a command that does not contain any slashes in the command name, it looks through the list of directories specified by this variable, separated by colons, and it looks for the command in each one of these directories in turn until it finds it. So that's variables, and a new way to put together commands with backquotes, which substitute the output of one command as part of another command. But we also need control constructs like if and while and such, and that's the topic of the second and third videos in this unit.